applying the laws of logarithms. There are three main laws: power, or product, quotient, power law. Okay? Think of product and quotient as multiplying and dividing. Power involves exponents. What do you think we need to deal with first? We've got, what's that? Exponent. Think BEDMAS, right? Exponents must be addressed before we can think about multiplication and division. And so when you are applying your log laws, what you want to do is scan the question, see if there is going to be a power law involved. And the way that you can tell is if there's a number written in front of the logarithm. If you see a number written in front of the logarithm, you have to apply that power law. Okay? So looking at these two, I don't see any number there. It's just log base 3 of 18 plus log base 3 of 3 over 2. But if I move on to the next one, I've got log base 5 of 40 minus 3 times log base 5 of 2. So when I see that 3 in front of a logarithm, that has to be dealt with first before I do anything else. And the reason for that really is that you can only apply product and quotient, meaning with the product law, when you add logs of the same base, you multiply their two values together. Or quotient, when you subtract logs of the same base, you divide. You can only do that if sort of the quote-unquote coefficient, if you will, of the logarithm is 1. So you can't apply those laws until this is 1, which is why we have to use that product, or the power law rather, first. Okay? Now in this question, we've got a product law going on. We're adding two powers, or logarithms rather, with the same base. What are we going to do? What are we going to do first here? Yep. Yeah, so log base 3, and then what happens to these two numbers, 18 and the 3 over 2? They multiply, yeah. 18 times 3 over 2. Okay, and that is 54 over 2 is 27, right? Or you could do that on a calculator. Take out your calculator, go 18 times 3 divided by 2. But this becomes log base 3 of 27. Is this something that we can evaluate? Yes. What's the value of this? 3, right? So you either, a lot of people can do these in their head if they practice it a bit. You're basically saying 3 raised to what exponent equals 27? And the answer is 3. Or if you need to take that extra step of like setting it equal to a variable and switching forms, even in this form, a lot of people are like, OK, I know that that's 3. Because 3 cubed is 27. OK? Now, in this guy over here, log base 5 of 40 minus 3 log base 5 of 2, we need to deal with this first. So this is going to come up here, and we're going to have log base 5 of 40 minus log base 5 of 2 cubed. Okay? The biggest mistake that people make with this particular question, does anyone know what it might be? Anyone want to take a guess? What do you think people might do with that 2 cubed? Yeah. Okay, if you divided 40 by 2 cubed, actually that would be fine. But what most people do, they don't write this step out, and they're just like 3 times 2 is 6. That's one of the biggest mistakes I see. So please take the extra step of writing this out explicitly, because 2 cubed is not 6. Right? What is 2 cubed? 8. Yes. So this becomes log base 3, no, sorry, 5. My 5 looked like a 3 there, of 40 minus log base 5 of 8. And now we can write it as a single logarithm, right? So this becomes log base 5 of 40 divided by 8. And 40 divided by 8 is 5. So here we are asking 5 raised to what exponent equals 5? 1, right. Okay? Now, some people can do lots of steps in their head without making mistakes. So if you see this and you're like, okay, I can visualize that 3 goes there, so it's going to be 40 over 2 cubed. And you consistently get the right answer when you do several steps in your head. That's fine. But a lot of people overestimate how many steps they can do in their head and consistently get the right answer. And you will have time, so just write those things down. Okay? All right, now, when you are looking at multiple addition subtractions, like this guy, there is a way to do this all in one step, but sometimes it leads to errors, particularly actually when there's a subtraction before an addition or several subtractions all at once. Okay? So what I recommend, although you can do it in one step, is do it in a couple steps going from left to right. So start with this, write that as a single logarithm, right? So this is going to be log base 6 of 9 times 4 is 36, and then minus log base 6 of 6. Okay? And then you can combine these together. Log base 6 of 36 over 6, which is log base 6 of 6. And what's that? 1, right. Okay? So same sort of idea here. Do you go from left to right? These first. 36 divided by 18. How much is that? Of 2, yeah. And then plus log base 4 of 128. And then you can multiply. So 2 times 128 is 256, I believe. Okay, and then try and evaluate that if you can. Does this one work? Can we evaluate this one? Yeah, so this might be hard to do in your head. 4 raised to what exponent equals 256, right? So this might be one where you want to set it equal to a variable. But even then, you're going to play around on your calculator. And what should that exponent be? 4, yeah. So x equals 4. Okay. All right. Let's do these 2 more. What do I need to address first here? The 3, right. So I'm going to pop this up here, and I'm going to get log base 2 of 4 cubed minus log base 2 of 8. Okay? And what's 4 cubed? Almost 64. Yep. Right? And then we can do our division. So 64 over 8 is 8. I don't necessarily need to see every step. A lot of people can do in their head 64 over 8, right? So that's 8. And then here, 2 to what exponent equals 8? 3, yeah. Okay, and then finally, this last guy, what are we going to deal with first here? Right, the 1/2. So we have to put that on 25 as the exponent. Okay. What's the value of 25 to the 1/2? When you raise something to the exponent 1/2, what's an equivalent thing to do? Square rooting, right? So what's the square root of 25? 5. So I'm going to have log base 5 of 5 plus log base 5 of 1. And then, of course, 5 times 1 is just 5. Okay? So 5 raised to what exponent equals 5? 1, right. Okay? So far, so good? Okay, so now we're going to do this with some variable values. Okay, so what we really have to actually keep in mind here are exponent laws, because when we combine logarithms, we're multiplying or dividing or raising a monomial to a power. It's all going to deal with multiplying, dividing monomials, taking a monomial, raising it to another exponent. And that's going to bring up the exponent laws. Okay? So for example, write the following as a single logarithm. Here we are adding these two logarithms together. So, and the base is the same, that's important. So this is going to be 2x times 3x. And then, of course, we want to simplify that. So 2x times 3x, how would that simplify? 6x squared. Exactly. Right? So 2 times 3 is 6. X times x is x squared. Exactly. Okay. Here we have log base b of 2x squared minus log base b of x cubed. So we need to divide. 2x squared divided by x cubed. Okay. Now, a lot of people have trouble with this. Does anyone know what the answer is going to be, by the way? We're doing like a quotient law for exponents. Yep. It is 2 over x, yes. So if you can just see that in your head, that's great. Be thankful that you have that gift, because not everyone does. Okay? But one thing that I find can really help people if they're getting stuck with this kind of thing is actually to do expansion. So off to the side, take this. X squared is x times x divided by x cubed. X times x times x. And then you can cancel common factors. So in the numerator and denominator, I have one factor of x, and then I have another one that cancels. And what's left is 2 over x. And then you'll get it right every single time. Make sense? All right. Let's keep going. Okay, so here we are doing a couple of log laws at a time. Of course, I should have mentioned this, but always scan to see if you have to do a power law first before you start working with product and quotient, right? So I don't see any numbers written in front of my logarithm, so I can just go ahead and, if it's a quotient law, I'm going to divide. If it's a product law, I'm going to add. Okay? So here, if I take a look at these two first, I need to divide. So I'm going to have log base a of x squared over x to the 4 plus log base a of 4x cubed. Okay. Now, some people like to simplify this first piece first. Some people like to just multiply it all, or like combine it into 1, and then do all your simplification. So I think I'm going to actually do it that way. Here I need to multiply. So this is going to become log base a of x squared over x to the 4 times 4x cubed. What would the denominator be here, by the way? 1, right. So some people find it helpful to like see them both as fractions. And so if you need to, put a denominator of 1 in there. You don't have to. It's up to you. But then now when I'm expanding off to the side, if I look at my numerator, I've got, and remember, multiplying fractions, you multiply numerators, you multiply denominators, right? So in my numerator, I'm going to have x times x, that's the x squared, times 4 times x times x times x. And in my denominator, I have just a string of 4 x's. Okay? And so now I can go ahead and cancel all of my common factors. So I've got 1 set of x's, 2 set of x's, 3 set of x's, 4 sets of x's. And so I'm left just in the numerator with 4x. Okay. Now what I will say is this is not necessarily the most efficient way of doing things, because you got to do all that expansion. But it does pay off, because exponent laws in Math 10C are an area of struggle for many, many, many people. And what I find is that if people struggle with exponent laws, if they start expanding to simplify, then what'll eventually, firstly, sometimes you just need to take that extra time, and then you don't make mistakes. But also what happens if you start doing this is you'll actually start to figure out the patterns and be able to skip a little bit and speed that process up. Okay? Whereas if you just rely on memorizing your exponent laws, a lot of times people make mistakes. Okay? If you'd like me to show you how to do this, though, just using exponent laws, I'm happy to do that too. Would anyone like to see that? Yes? No? Maybe? I can talk it through, right? If I'm looking at this one up here, for example, quotient law, so I'm going to subtract. So 2 minus 3 is 2x to the negative 1. Because I have a negative exponent on x, I have to bring it down. Okay? Here, if I look at this piece, in the numerator, I have to add exponents. So 4x to the 5 over x to the 4. I'm going to subtract. I get x to the 1, 4x to the 1. Okay? So if you are really good at that, do what's efficient, right? But if it is an area of struggle, this really helps people get the right answer every single time. And so take that time and do it. Okay? All right, what do we have to do here if we want to write this as a single logarithm? Yes? Multiply by 2? Yes, this becomes an exponent. Okay? So that's going to give me the log of 3x squared. Okay? Now the most, or not the most common, but the most common error that I see is people write log 3x to the 4. And that's wrong, because 3x squared is 3x, or squared rather, 3x squared times 3x squared. That 3 also needs to be squared. So altogether, you're going to have actually 9x to the 4. Okay, so this becomes the log of 9x to the 4. All right, so far so good? Okay, so I am going to get you guys to practice these ones, and then we'll talk about a couple other questions as well. And then there's just going to be lots of practice. And this is a standard of excellence question. Okay, so this type of question you can expect like maybe 1 out of every 5 questions to be like this. Personally, to be honest, this isn't, I don't think, that much harder, but this is what they tell me from Alberta Education. Okay. But essentially, it's considered standard of excellence when you have to work with several laws at a time, and one of them's a power law. Right? So that's when we have to scan the question, see if there's any numbers in front of the logarithms first, like this one, and pop that over here. Right? In this question, I've got a 3 here, so I'm going to pop that over there. Okay? That's considered standard of excellence. And I suppose a couple things that make that hard. Number 1, people don't forget to do it. So that's the first thing that trips people up. And then the second thing is that people do have trouble expanding 2x all squared, right? That can be a challenge for some people, or at least it can be a place where you kind of forget what to do. So tips, number 1, get into the practice of scanning all questions to see if you have numbers in front of logarithms, because those always have to be addressed first. And number 2, if you're finding like you're guessing with your exponent laws, expand. Okay? This is going to become log of 2x squared minus log of x squared. Okay? And then you could even do it off to the side. 2x squared is 2x times 2x, squaring the whole thing. So 2 times 2 is 4. X times x is x squared. So my next line is going to be log of 4x squared minus log of x squared. Okay, and now I can do the quotient law where I divide. 4x squared over x squared. And then here the x squareds rather cancel. So you're just going to be left with log of 4. Okay? In this next question, we're going to have the log of 2x plus the log of x squared cubed. Okay, so again, if I expand this, x squared times x squared times x squared, you could even expand each of those out, right? Each of these has 2 x's in it. 2 x's, another 2 x's, another 2 x's. All together, that's x to the 6. And again, if you don't need to take this step, you don't have to. I'm just trying to like put some strategies in place for people who kind of struggle with exponent laws. Okay, and now I can multiply. Okay, what is 2x times x to the 6? 2x to the 7. Yeah, and again, if you can't get there, just expand that, right? It's 2x times 6 x's. 1, 2, 3, 4, 5, 6. And you'll see, okay, there's 1, 2, 3, 4, 5, 6, 7 altogether. Log of 2x to the 7. Yes?
I'm confused. Wouldn't it be 3x to the 6? Aren't you, like, multiplying the base number as well, which would be 1?
Okay, no, but what it is actually is it's 1 cubed, right? You're adding that exponent to that coefficient. 1 cubed, though, is just 1. Yeah. So if that coefficient is 1, you don't actually need to worry about it. Yeah, good question. All right. So the next, I'd like to give you guys maybe, I don't know, 10 minutes or so to do these next few practice questions, and then we'll see where we're at. That's the end of this lesson for today. So I'm going to actually stop the recording now.